Hello, my name is Daniel Quirk and I'm here to give you a presentation on vCloud Director Design and Scale. And what we're going to talk about within this presentation is the design aspect of vCloud from where us as VMware would recommend you, but also the choices that you make in the underlying infrastructure. And we'll see how those affect your overall design and your ability to scale. Now, for the purpose of this presentation, when I talk about underlying infrastructure, I'm talking about the product infrastructure, so the products that make up vCloud Director itself. So today for the presentation, we're going to talk a little about vCloud Director. So I'm going to give you an introduction to vCloud Director, and this is for those of you who haven't dealt with vCloud Director before, but hopefully some of the areas we touch upon in here will act as a reminder for those of you who have dealt with vCloud Director before. Then we're going to move on to the more in-depth stuff. So we're going to talk about deployment designs. And here we're going to talk about the deployment designs we see that would come into us here via a support request. But also, I suppose, the recommended deployment design that we would ask customers to implement. We're going to talk a little bit about our key config maximums, because they are things which are going to affect our overall design. And in this section, what we're going to talk about is the key config maximums in relation to vCloud and vCenter, but also our product infrastructure that we touched upon earlier. So in this presentation, we're going to use NSX and vSAN as examples. What we're going to see there is how the key config maximums of all those products influence our design and our overall scale. Then we're actually going to go on to our designing section. So we're going to talk about designing a vCloud deployment, and here we're going to talk about the recommendations from VMware, but also the choices that you make underneath. And then we're going to see, because we've completed all of the areas previous to that, we're just going to do a little example on scaling it out. So we're going to see how all of the choices that we've made up until that point affect our ability to scale. So an introduction to vCloud Director. And as I mentioned earlier, this is going to start from the beginning of I suppose, what is cloud computing, and we're going to move into what vCloud does and how it does it. So I suppose an introduction to what a cloud is. So it's a logical abstraction of physical resources, and at the end of the day, all a cloud is a customer will buy a subset of resources, and it's up to the service provider then to actually look after the back-end servers and things like that. A cloud at the end of the day is to provide an as a service. So some of the more prevalent ones that we see quite often will be an infrastructure as a service, platform as a service, software as a service, and anything as a service. So an infrastructure as a service would be what vCloud Director is. So you're given a subset of compute resources, and it's up to you to develop your infrastructure as to what you intend to use it for. Platform as a service is slightly similar to infrastructure as a service, but the platform is pre-configured for a specific reason. So for example, an application developer will want to develop an application, but he doesn't really care about setting up the infrastructure to allow him to do so. So he'll purchase what's called a platform as a service. Software as a service, on the other hand, would be anything that you'd link into to use your browser. So the likes of an email system, or some of our products here, such as ITBM Business. Anything as a service then is more for what service providers are looking to go towards. So a service provider wants to be flexible enough so that if a customer comes to him on a Monday and says they want something from an infrastructure, Tuesday a platform, and Wednesday a service, then they're able to do so. And some other terms that you might hear floating around the place will be public, private, and hybrid. And again, this is just the actual cloud end customers and what it's geared towards. So if you developed a cloud that was geared towards external customers, so people not within your own organization, then that would be a public cloud. A private cloud is like that, but it's geared towards internal people only. And then a hybrid is a mix and match of both of those. So now that we know what a cloud is, what is a vCloud Director? So as I touched upon earlier, vCloud Director is an infrastructure as a service offering, and what we're using it for is to build and manage a VMware vSphere cloud. It has full integration with products called NSX and vCNS for networking and security. So I've touched on NSX earlier. vCNS, on the other hand, is just a predecessor to that guy. So if you want, think of NSX as vCNS bundled with the Nicira module. And what that's going to do is it's going to give us our networking and security features within cloud via what are called edge or edge gateways. As I mentioned, it's built upon the VMware vSphere, so it's going to be based upon our software-defined data center architecture. And when we have a completely built, what vCloud gives us is the ability to have granular management of our compute, networking and storage resources. Now, some terms that we're going to hear quite often when we're going about designing our infrastructure would be converged versus hyper-converged. Now, these are more geared towards the underlying aspect of it, and again, we're not going to go into a huge amount of detail on it, but I do think it's a key notion that we need to touch upon. So converged versus hyper-converged merely just looks at the approach that you're going to take for building your underlying infrastructure, and these are geared towards scaling out rather than scaling up. So converged would be for the backing of, we'd say, hardware, and that will be the likes of the VCE vBlock. So for each time you need more resources, you're going to add another vBlock rather than adding hosts into your cluster. Hyper-converged, on the other hand, would be taking a software-defined data center approach to that. And because we're using NSX, which is our software-defined networking, and vSAN, which is our software-defined storage, we're taking more of a hyper-converged approach to it, but we're not totally hyper-converged. If we were totally hyper-converged, we would be talking more along the lines of EvoRack and EvoRail. So let's move on. So for those of you that have worked with vSphere, we'll talk about how that integrates with cloud and what we look at in terms of what we know as opposed to what vCloud is. So you can think of vCloud as a subset of vCenter resources, and in vCloud we'd call that a provider virtual data center. A provider virtual data center, then, if you want to think about it, is merely just a subset of resources from a cluster or resource pool. If we were to take that provider virtual data center, and again just take subsets of those resources, then we'll get what are called organizational virtual data centers. We will then sell those to a customer or tenant who actually purchases their own organization. So if you want, you can think of an organization as an independent container for org VDCs. So all we're saying there is a customer buys an organization, and that's their gateway into managing the resources that they've purchased. So again, for the vSphere guys, you can think of a provider VDC as a resource pool, and then you can subset those guys into one or more organizational VDCs. So again, all we're doing is carving out resources of it, no different to what resource pools are used for anyway. And one thing I haven't touched upon, which I'll touch upon now, is the system VDC. So this is similar to an organizational VDC in terms of it comes underneath a provider VDC, but this cannot be sold to customers. A system VDC is to provide features and functionality within cloud, but not force the customer to consume resources to do so. As I mentioned earlier, we will have security and networking features through our edge and edge gateways. So the system VDC will be used to place these service VMs, and the amount of resources that they consume is then taken up by the provider rather than an organization VDC. So one tip we would have is do not disable DRS. As we've touched upon, vCloud is leveraging resource pools to provide resources, and if any of you have been unfortunate enough to disable DRS before, you know that disabling DRS will delete all resource pools. Because cloud is built on resource pools, if we have no resource pools, we have no cloud. And that leads us into a frequently encountered issue that we would see here in support. So a customer would come into us saying that we're missing resource pools, or that I can't deploy an edge. And when they say I can't deploy an edge, it'll usually be I can't deploy an edge, and in the logs it will say cannot find resource pool X, and again that'll be your system VDC. And the cause of that is the system VDC has been disabled. Now in support we do have two solutions, but the first one will be the recommended approach, and that would be to restore your vCloud and vCenter DBs. So as it functions, vCloud takes in information from vCenter and it stores it in what are called the inventory tables. So the inventory tables, I suppose, would be the information that vCloud has about vCenter at this current point in time. So what you can do is when we restore the vCenter and vCloud databases, If those guys are out of sync by any way, what we're going to have is resource pools that don't exist in one but do in the other. So it is important that we restore these both at the same time and at a point in which the backup was taken. So the backups need to be taken within a short period of time between each other, because we don't want differences. Another solution that we would have is we have an in-house script which is used to restore it based on those inventory tables. But what we've seen happen is that it sometimes doesn't create the system VDC, or the links in the database aren't correct. We have a KB there, is KB2073392, and that will go through the updates that need to be done to fix those links. But again, because DRS is such a huge part of your infrastructure, I'd recommend contacting tech support if you do have any issues. So again, just to recap on what is vCloud, so we can think of vCloud here as being something that we'd offer to customers. Now vCloud itself needs resources, and that's pushed up from our vCenter and vSphere layers. So what you can think of cloud is a chunk of virtual data center resources, so the likes of storage and networking, and then that's secured via our vShield or NSX edges, so they'll provide our networking and security. So what a customer sees at the end of the day is they'll have their own unique portal, which they'll use to manage their resources. They'll have catalogs, again, which they can use to copy, upload and deploy their VMs. And they'll have security as a service, so to speak, via their edges. So that can do the likes of VPN, NAT, firewall, things like that. So a frequently encountered issue we would see, and again this is something that has come up quite recently, would be customers stating that they can't upload or download OVFs or VApp templates when behind a proxy. So the cause of this is that the OVF tool, which is new in 5.5, it's a standalone product which launches on the client, and that's used to upload the media and OVFs. So what happens is this product itself is unable to acquire the correct proxy settings. Now the issue is going to be released in a future release of 5.5, and a workaround for the moment would be to download the standalone OVF tool, not the one that's bundled with Cloud, and you can use that then to upload your ISOs or templates. We have a KB there 2091030, and I'd recommend checking in on that KB, maybe subscribing to it to be alerted when changes are made. So deployment designs. So a common deployment design that we would see come in via an SR would be a customer with a single installation of vCloud or SSL, so that's what we'll probably refer to it from now on. Single vCenter, one or more provider VDCs, and multiple hosts and VMs underneath. What that actually gives us is a high load and single points of failure. So to illustrate that, let's think of just a single vCloud cell, single vCenter managing multiple hosts backed by multiple data stores. So a recommended deployment design will be to take those high loads and single points of failure, and what we want to do there is we want to share that load, we want to introduce redundancy, and we also want an ease of scale. So to illustrate that, what we want is we want to take our single instance. First we want to share the load, we want to introduce some redundancy, so here we're going to add some extra cells, and again for each vCenter that we have, the rule of thumb would be to add n+1 times the number of vCenters. So in our example we have 2 vCenters here, so we'd have n+1 cells, so that would be 3. And again these cells need to have a shared database. And because we're going to add our redundancy out in front, what we also need to do is we need to throw a load balancer in front of that to divert our requests. So key config maximums. And as I touched upon, we're going to talk about the config maximums for the products. So we're going to talk a little bit about some of the config maximums, but as you know, the product config maximums range in hundreds to thousands. So just to remember that the maximums that we're going to talk about here are tested maximums. These aren't something we're going to introduce ourselves, but they're going to be scenario maximums, so they're going to pertain to a vCloud setup only. If you were to have the likes of Horizon View, then some of these maximums may not apply. And what we want from these maximums is we want a happy medium. So we want to keep below our maximums, but we want to be able to utilize the environment as much as possible. The first set of product maximums we're going to talk about will be our NSX and vSAN maximums. So with NSX, and what you'll notice here is that it actually has a clusters maximum, so no other product that I've seen to date actually controls the amount of clusters that you can have within vCenter. So as we can see here in our diagram, that's set to 12, so that's going to be the defining maximum within our environment. The other one we're looking at here is our NSX controllers, and the maximum there is set to 3. Now we did mention that we want to stay below our maximums, but unfortunately this is one maximum that we can't set below, because if we go below this, NSX uses a majority ruling. If we have 2, you don't have a majority, and if you have 1, you have no redundancy. So we're stuck with 3 in this scenario. vSAN then, on the other hand, has some slightly different maximums. So the ones we're interested in here would be our VMs per host maximum, and with vSAN that's 100. The maximum number of disks per host, which is 35. And when we're talking about the number of disks here, we're actually talking about the magnetic or storage disks, not the actual SSDs. And the actual total storage per vSAN cluster, that's a maximum of 4.4 petabytes. And again, what that's based off is the total number of hosts per cluster in a vCenter. So that's a vCenter maximum, and we'll touch upon that later, which is 32. And the total number of disks, which is 35. And again, that cumulative value is just multiplied by the largest SAS disk currently available, which is 4 terabytes. So let's move on to our vCenter and our vCloud maximums. So as I mentioned, we have a host per cluster maximum of 32, and we have VMs and host maximums here, which are 10,000 and 1,000 respectively. Now when I'm talking about our VMs per vCenter, I'm actually talking about the maximum powered on VMs per vCenter. So that's 10,000. The registered number of VMs is 15,000, but we're looking to utilize the environment, so we're going to stick with 10,000. The 10,000 and 1,000 VMs and hosts, that will actually be limited by the type of database that you use. So if you use the embedded Postgres, you're limited to below these values. Now in relation to vCloud, we're going to talk similar maximums. We're going to talk about the maximum vCenters, hosts and VMs. So the maximum number of vCenters will be 20, hosts per vCloud will be 3,000, and total numbers of VMs will be 30,000. So let's talk about design. So in this section we're going to talk about our vCloud director, so the key design areas here, and these would be the recommendations from VMware, and the infrastructure and how that designs to scale. So again, the infrastructure here, we're actually talking about the product infrastructure, not the hardware. So our vCloud director key design areas. So we're going to talk about our vCloud networking requirements, provider VDC creation, understanding allocation models, vCloud network pools, vCloud storage, and load balancing. So networking requirements. So one of our requirements will be IP addresses, and for vCloud we require 2. One for our HTTP traffic and one for our console proxy traffic. Now the console proxy will be used for VM remote consoles, whereas the HTTP is used for all of our UI traffic, but also our uploads and downloads. As we touched upon, we have a console proxy address, and this is used for our VM remote traffic. And what we have here is we have a requirement that the console proxy address requests go direct to the cell, and they're not going via an SSL terminating load balancer or reverse proxy. One of the requirements that we'd have is that we'd have a network time service configured within the environment. So this would be something like NTP, and our recommendation is that we have all sources, so we have vCenter, vCloud, ESXi and underlying database on the same NTP source. And the maximum drift we allow here is 10 seconds, but again, this would be recommended to keep lower. Hostname resolution is also another requirement that we'd have. So for every fully qualified domain name in our environment, we need short, long and reverse lookup to be configured correctly. So an example would be vcloud.vmware.com. We need vcloud.vmware.com and vcloud to map to the same IP, and we also need that IP to reverse lookup back to vcloud.vmware.com. We also have transfer storage. So for each cell that we have, it needs to be mounted to the same shared storage area. And what this is used for is a temporary storage location for our uploads and downloads. Although it's not mentioned in the documentation, SSL certificates should be a requirement, but again, this requirement only takes effect if you're using CA signed certs. So a tip that we would have here would be that the DNS resolution in your environment matches the SSL certificate common name. Now the thing is, and not a lot of people are aware of, is there's a field in an SSL certificate called a subject alt name, and this takes precedence over a CN field or common name field when used. So if we have the likes of vCloud.vmware.com, and an alternate name of that would be maybe vCloud as the short and an IP address. If we don't have vCloud.vmware.com again within the subject alt names, that's going to cause issues with our certificates. One thing we need to keep in mind as well again is that we've touched upon that we have two possible FQDNs. So we have our HTTP and our console proxy. So that requires two certificates. So two certificates, two FQDNs. Two sets of DNS resolution need to be configured correctly. And the last thing we're going to touch upon here is our vCloud public addresses. So this is an area within the UI where we get to set what we want to send back to the client when it makes a request. So we'll fill in information about HTTP, console proxy and our API. If an API request comes in, that's the information we send back, and vice versa, the same with our HTTP and console proxy. So one thing to keep in mind with that as well is that although the information in here does need to match what we have set in our DNS, but also in our certificates, if we don't have any information in here, what we're going to be sending back is the actual local addresses of vCloud itself. So provider VDC creation. And again, just to touch upon them again, so our provider VDC is going to be a subset of vCenter resources. It's going to be the total amount from a vCenter if there are no other provider VDCs in use. And one thing to keep in mind, which a lot of people aren't aware of, is that the provider VDCs can expand. So we can throw more resources at them as and when needed. And this can be in the form of hosts into a cluster or a resource pool. And again, just to keep in mind that even though you might start off small, you can again scale out. So when we're creating our provider VDC, one thing we need to keep in mind, and one recommendation that we would have, is that when you're creating it, you'd create it under a resource pool rather than under the cluster. So for those of you that have worked quite a lot with vSphere, you will know that a cluster is the highest level of resource pool that you can have within vSphere. And similarly, a provider VDC is the highest level object of resource that we can have in cloud. So if we're creating it on the cluster, what we're actually saying there is our parent object is a parent object in vSphere. So if we're going to create another provider under the same cluster, what we're actually doing there is we're trying to make a provider VDC a child of another provider VDC, and that logically does not make sense. A provider can't be the parent of a provider, it's the parent of an org VDC. So again, do not use the cluster, use a resource pool. So the next section here will be understanding allocation models. And an allocation model is used for organizational VDCs, so a subset of the provider VDC resources. And what an allocation model actually does is it defines how the compute is actually consumed within the underlying vSphere. So within vCloud we have three allocation models. We have an allocation, pay-as-you-go, and a reservation. And before we can get into a lot of detail with these guys, we're going to need to talk about what's called an elastic VDC. So an elastic VDC, so you might hear the terms elasticity and elastic VDC. And all we're saying there is that the resource pools that are used to create our org VDCs, that they can pull from another source as and when needed. Now the allocation and pay-as-you-go by default are fully elastic now within 5.5. The reservation is not. And again, this is because the allocation and pay-as-you-go can pull from other resource pools, whereas the reservation is confined to a single resource pool. Prior to 5.5, the allocation model needed to be enabled to be an elastic, and that was done via a config flag within the UI, and that would be found in the system settings, admin tab, and general settings. And down below at the bottom of that page, you would see a flag there just allowing you to make the allocation pools elastic. What elasticity actually allows, or what an elastic VDC also allows us to do, is it allows us to give vCloud complete control over whether the VMs can power on or not. So if the allocation model is not elastic, the VM admission control is within vSphere, but when it is elastic, we're allowing vCloud to make that choice. And another important thing of an elastic VDC is that we're pushing the VM overhead up into the provider, so the provider needs to look after the VM overhead rather than an org VDC itself. And again, this just comes back to people purchase resources or purchase an org VDC. They want to be able to consume 100% of that, not 98 or 95, which is where the VM overhead comes into play. So now that we've talked about our three allocation models, we've discussed elasticity, let's talk about the actual models themselves in a bit more detail and exactly how they differ and what they're used for. So with our allocation pay-as-you-go and reservation, we're going to talk about them under certain topics and we'll see how they differ. So the first one we're going to talk about is limits and reservations. And what we're talking about here is where we're allowed to place these limits and reservations by our configuration. So when we're creating an allocation model, what we're actually doing is we're setting resource pool level limits and reservations only. Now, a guarantee factor that we have here does push some of those values down to the VM, but what we're actually only doing here is we're setting stuff at the resource pool level. Pay-as-you-go, on the other hand, is completely different, and that's VM level only. So when we're creating our org VDC, we're actually not setting anything on the resource pool. We're just setting things at the VM level. Reservation then, on the other hand, is like a combination of both. So when we're configuring our org VDC, we're going to be setting resource pool level limits and reservations. And as we deploy our VMs, we're going to be doing a per VM limit and reservation. By default, these will be 0. So keep that in mind if you do have a reservation model, that you will need to set something at the VM level if you're looking to limit and guarantee it. In terms of the committed resources with an allocation model, that will be partial. So for all the resources that we're getting from our provider, we're committing a subset of those, not all of them. With a pay-as-you-go, we're committing our resources only at power on. So with the VMs, if they're deployed, we're not consuming anything. When we hit the power on, we're dynamically pulling those resources from the provider. With a reservation, we're committing all of those resources immediately. So a system admin, which would be the service provider, will give the customer a subset of those resources, and that is given to them to do with as they wish. We've talked about elastic or expandable, as some people may refer to it. And with allocation and pay-as-you-go, we're fully elastic so that we can pull from anywhere as and when needed. With reservation, we're not elastic, but we are expandable to the degree of the actual provider VDC. So we're able to take as much resources as that provider can actually give us. And again, they need to be configured to be given a can't pull it as and when needed. The next one we're going to talk about here is relocate VM at power on. And this is a feature of elastic VDCs. And again, a secondary resource pool needs to be configured with it. So what we're saying here is that if the primary resource pool or the org VDC's initial resource pool, if that doesn't have the resources to facilitate a power on, we can move that into the secondary resource pool. And as I touched upon, the reservation is stuck to a single resource pool, so there's no way we can relocate the VM at power on. In terms of a VM resource guarantee, all we're saying here is that can we configure a guaranteed resource? Like, do we know exactly what we're going to be guaranteeing? With the allocation model I touched upon earlier, we do set a value at the org level, which does factor into the VM. But again, we don't know exactly what that's going to be, so we don't have an actual guarantee that we're configuring. Pay-as-you-go on reservation, because we're setting stuff at the VM level, we are actually putting on a guarantee here. In terms of overcommitment, it's not easy to take that as a kind of a yes, no, or black and white, because we need to look at it from the perspective of system and org. So what we're here is saying from the perspective of the service provider and the customer or tenant. So with an allocation and pay-as-you-go, we're setting there the amount of resources that we're going to allow it to consume. So we are able to specify our overcommitment. And again, overcommitment, all we're saying here is at that level, are you specifying a percentage guarantee? That's all we're saying, no more, no less. So with the allocation and pay-as-you-go, we are setting something there at the system level, or I suppose when we're configuring it for the customer. And at the reservation, we're not setting anything. We're giving that person full control over those resources. With our overcommitment at the org level, you'll see that that's directly the opposite of it. Because we've specified a percentage guarantee at our system level for the allocation and pay-as-you-go, then we're not able to do anything at the org level. So an org admin isn't able to control overcommitment for these guys. With the reservation model, again, that's completely different because it's per VM. So we're getting to specify exactly how much of the resources that guy is consuming. So going off that, a recommendation that we would have here in GSS would be to not mix and match the pay-as-you-go and allocation models or reservation models under the same provider VDC. As the allocation models and reservations reserve some or all of the resources, and the pay-as-you-go is dynamic, then we can't really see exactly what we're going to be allowing for our pay-as-you-go model. So a recommendation there would be pay-as-you-go would be a separate PVDC. And again, we're just going to talk about this here now in a little bit more detail. So a frequently encountered issue that we'd see because of a pay-as-you-go model would be that a customer would say that they cannot start any VMs in a pay-as-you-go VDC, or that they'll see the error. Deployment of virtual machines in this organization VDC has been disabled due to insufficient resources in the provider VDC. And a cause of that is that the CPU or memory resources are overcommitted by a pay-as-you-go VDC. So we touched upon a bit that we cannot forecast exactly what we're going to utilize with our pay-as-you-go models. We're going to allocate it, and that's fair enough, but we don't know what's going to be powered on and when. So we don't know at any one point in time how many of our resources from a provider that we're actually going to consume. And it's a feature within vCloud to stop you consuming all of the resources in your provider at one time. So what happens here is a flag is actually set in the database to stop the pay-as-you-go power on operations. Now the flag actually needs to be unset in the database itself, and it's a fairly trivial task to undo that, but again, because it's in the database, it is recommended that you contact tech support to perform that actual database update. So the next area we're going to talk about is vCloud networking pools. Within vCloud, we have 4 types of networking pools. We have port group backed, VLAN backed, vCloud networking isolation backed, and VXLAN backed. And just like our allocation models, the networking pools are used to define how our networking resources are consumed. As we mentioned, we have 4 types of networking pools. Now we're just going to go into a bit more detail on how those compare and how they contrast. So as we look at it, we have 4 networking pools. And what we actually have is we have 2 groups. So a port group and VLAN will be very similar, and similarly VCDNI and VXLAN are very similar also. So with a port group, this is going to be our basic building block. And what we need to do with this, guy, is we need to pre-create our port groups within vSphere. So if we've no pre-created port groups, we can't create a network backed by port groups. Now with this, we're still going to need our layer 2 segregation, so we're still going to use VLANs. The advantage of this, guy, is that we're not limited by any switch type, so we can use a standard switch or distributed switch if we like. The number of port groups is a limiting factor here on it, and when I'm talking about number of port groups, I'm talking about number of pre-created port groups. So those guys need to be created in the background. VLAN similarly is very similar to port group backed, but what we're doing here is we're dynamically creating those port groups. So with port group and VLAN, we're going to be using port groups that are going to use VLANs for the segregation. The only difference really here is that the VLAN backed port group will dynamically create those guys for us. So an advantage of that is it provides dynamic layer 2 segregation. One disadvantage of it, and it's I suppose very similar to the port group one, is that we're limited by the number of VLANs that we have available on our physical infrastructure. Now that we've talked about the first grouping, let's talk about vCDNI and VXLAN. So with port group and VLAN, they work in a similar fashion. This is the way vCDNI and VXLAN are similar also. They will use overlay technologies or encapsulation to provide our segregation rather than the use of multiple VLANs. So vCDNI is going to give us a segregation via our Mac in Mac encapsulation. And because we have an encapsulation, what we can require there on that side is an MTU increase on our physical infrastructure, but also on our distributed switch. So an advantage is that it's going to give us our isolation without the use of multiple VLANs. And we also have a 24-bit network identifier, which gives us a theoretical number of 16 million networks, but we actually have a code limitation with vCloud, which limits that to 1,000 networks. The thing with vCDNI as well is that we're limited to a single active NIC, so that we reduce the amount of duplicate packets within our network. VXLAN is very similar to vCDNI in that it provides an overlay, but its MAC in UDP is what that's using for the encapsulation there. One main difference between vCDNI and VXLAN is that VXLAN is designed for cross-cluster networking, whereas vCDNI is for cross-host fencing or cross-host networking. With VXLAN, we also require an MTU, and the recommended one there would be 1600. And again, this needs to be placed on the physical, but also on the distributed switch. I've mentioned here that a requirement would be for multicast, and that's for VCNS, sorry. So with VXLAN, the controllers, as we mentioned earlier, when they're set to unicast mode, they don't require multicast to be set up on the physical infrastructure. With VXLAN, we also have a 24-bit identifier, but we're not limited by any code here, so we can use up to the maximum of 16 million plus networks. VXLAN also allows us to take advantage of NIC teaming, so any NIC teaming types that we have out on our physical can be utilized with VXLAN, and this occurs when we're actually doing the preparation of the clusters. Now the only disadvantage of VXLAN, and again it's not a true disadvantage, it's more of a hard requirement than anything, is that we need vShield or VCNS or NSX to actually prepare the cluster. Now you can use a Cisco Nexus to manage your VXLAN setup, but it does need to integrate with vShield or NSX to be able to prepare the cluster. So this brings us on to a frequently encountered issue that we'd see here in support. So a frequently encountered issue that we might see is that a customer might report that either VMs are dropping packets, there's a loss in connection, or that they simply can't communicate using a vCDNI networking pool. And the cause of this generally comes down to a number of factors, but we've seen it occur due to such things as NIC teaming on the physical setup or fence information on the host. So when I say fence information, this is what's used on the host to encapsulate and decapsulate the traffic, but it also really defines whether the actual packets can take place within a vCDNI communication or not. So a solution would be to ensure that NIC teaming is disabled on the physical switches. When we're talking about NIC teaming, we're talking about anything there that's going to allow us to use an active setup. When we're verifying if we have fence information on the host, there's a command that we have here. So it's ESX CLI vCloud fence get fence info, and that will give you back the fence info if it's present on the host. If the fence info is actually missing, then this host is not able to encapsulate or decapsulate traffic. So the actual Mac in Mac encapsulated packets will be dropped. And again, if this is missing, what we need to do is we need to re-prepare those hosts from vCloud Director. A tip that we would have for our networking pools would be just to remember that the org-VDC network pool settings can be changed at any time. So the setting applies to new power-ons only. So if we power cycle the VAP, it'll actually force it to switch over for us. So the next area we're going to talk about here is vCloud storage. And vCloud storage is slightly different to the way the networking and compute resources are consumed, in that we don't have a lot in terms of customization as to how these are consumed. We do have some settings at the system and org levels which will define how it's consumed within vSphere, but it's not as advanced as that of the compute and networking. So the settings that we're going to look at here are thin provisioning and fast provisioning. These are set at the org-VDC level. So again, these are particular to each and every customer. We'll also have data store thresholds. So thin provisioning, just like in vSphere, just means that the total amount that we're actually consuming on the disk is all that's actually consumed in the data store below. So for an example, a 40 gig disk, if we're using 10 gig of that, that's all that will be consumed within vSphere. Now the thing to keep in mind is that vCloud is still going to treat this completely as a 40 gig disk, because it needs to know the maximum size to which this disk can grow so that it can be used correctly for calculations. So please just keep that in mind. Fast provisioning, on the other hand, or linked clones as it may be called, that is totally different to TIM provisioning. What this is actually doing here is it's creating a duplicate of a VM, but rather than having two complete base disks, what we'll have is one base disk or one full clone, and then the secondary or duplicate VM will be pointing to this base disk and using delta disks or snapshots to track the changes. Within vCloud, we can't span data stores, so if your vCloud deployment happens to push your duplicate VM to another data store where that base disk doesn't reside, it's going to create what's called a shadow VM. And that shadow VM is a full copy of the actual base disk. And although it is called fast provisioning, anytime we have to create a shadow VM, it's going to be a full clone, so it isn't going to be fast. Data store thresholds then, on the other hand, is a system level setting, and it applies to all your data stores. And what we're doing with data store thresholds is we're just setting a total amount that needs to be free on the data store. So we have what are called yellow and red thresholds. And a yellow threshold is more of a warning, just to tell you that you're consuming too much storage and you will need to purchase or allocate some further storage in the future. A red threshold is you've gotten to a point where you no longer have storage that you want to be consumed for cloud. So a red threshold will stop you from doing power runs, uploads and things like that, whereas a yellow threshold will just give you a warning. So a tip based on these settings, and as we touched upon, TIN provisioning is very simplistic. It's either TIN or it's tick, there is no difference. So the tips that we're going to give here are based on the fast provisioning and data store threshold settings. So with fast provisioning, we'd recommend that you consolidate VMs within the catalog, and things to keep in mind there, that consolidation can only be done by a system admin. And when we're saying within the catalog, we're just ensuring that the VM that is copied to the catalog is not an actual linked clone. One issue that we currently have is that the consolidation within vCloud fails in vSphere if VAI is enabled on the underlying data store, and that's something that's currently under investigation. I do not have details as of this presentation, but as they come available, they will be made available to you. Another recommendation would be to pre-create shadow VMs. So as I said, the shadow VM is going to be the slowest part of the fast provisioning deployment. Now, to pre-create a shadow VM, what we need to ensure is that we don't have access to either the base disk or another shadow VM on the data store that we're deploying to. So what we need is to disable those data stores to force it to go somewhere else, and to pre-create the shadow VMs for us. And all we're doing here is we're speeding up the entire fast provisioning infrastructure that we have. In relation to our data store thresholds, a recommendation that we'd have would be to recreate or reconfigure the data store thresholds. So by default, vCloud will set these high, and as we said, the data store thresholds is the amount of space that needs to be free on the data store. So if we're setting it high, then all we're able to utilize is like maybe 10-20% based on the initial vCloud settings. So again, take a look at these and set them accordingly. Also with data store thresholds, as the name indicates, they're for data stores, not data store clusters. So if you do have a data store cluster, ensure that you're setting a low threshold. Because if you're setting it at a cluster, what it's going to do is it's going to push that value down to each and every data store within that cluster. So an example would be a 3 data store cluster with 200 gig disks. So we'd have 600 gig in total within our data store cluster. And if, for example, we said we wanted to keep half of that, so we want to set maybe a red threshold of 300 gig to ensure that cloud can't use any more than that. What we're actually doing there is we're pushing a 300 gig limit down to each of our 200 gig disks. which means that we won't be able to do any deployments. So the last section in our vCloud Director key design areas is load balancing. So an illustration here just shows the requests coming in from the customers, hitting our load balancer, in this example a vShield Edge, and what that's doing then is it's just pushing the requests down to one of the cells for it to be processed. So when we're configuring our load balancer, there's 4 key areas that we need to be aware of. So these would be our ports that we're using, persistence mode, high availability, and our balancing mode. So with ports, we need to ensure that we configure 80 and 443 for our connections. Our persistence mode, again, this is not a recommendation, it's down to a customer's prerogative. But what we're looking at there is something like sticky sessions or cookies. So with sticky sessions, what we're saying is that the first backend web server to handle our request, we're going to utilize that for the rest of our session. And again, with something like that, if that cell happened to go down, what's going to happen when it needs to fail over? Cookies, on the other hand, will be more client side. So we'll have something stored on our client, which is then fed to the load balancer as we connect. And that gives the load balancer the freedom of choice in terms of the backend cells that it's going to use. High availability is a feature that may not be available to all load balancers, but if it is available, you need to ensure that we're utilizing it. Because one of the key things that we did touch upon earlier in this presentation is that we want to ensure that we have as much redundancy as possible within the environment. So we would like high availability to be configured to allow us to have redundancy for the load balancer. And the last thing we need to keep aware of when we're configuring is our balancing mode. So here we have a recommendation in VMware to use either round robin or least con. So with round robin, we're going to use every second cell, and then with least con, we're going to use the guy which is least utilized. So least con might be something that you'd use in your environment if you notice that one of the cells is used more often than the rest. So a tip when configuring our load balancer will be around SSL termination and SSL certificates. So for those of you who aren't aware, SSL termination pretty much just cuts the communication at a certain point and creates a new connection from there on. So in our example, what we would have is we would have clients connecting to our load balancer and then the load balancer to our cells. So there, if we had SSL termination enabled, what we would be doing is we'd be creating a connection from the client to the load balancer and a separate connection from the load balancer to the cell. So as we touched upon earlier with vCloud, we're going to be using our OVF tool to do our uploads. So what we need to ensure is that the SSL certificate on the load balancer and the cells must match. Because if we're doing the upload, what we're going to have is the possibility of 2 separate thumbprints there. So as I mentioned, OVF tool connects to the load balancer and then it will connect to the cell. So if those 2 certificates are different and we have SSL termination enabled, what we'll have there is a possibility of 2 thumbprints. And because we don't get a match, we won't get an upload. And you'll see something similar to that effect in the UI. Cannot upload due to thumbprint mismatch. If we don't have SSL termination enabled though, we don't need to worry about this. Now that we have our load balancing configured, let's move on to how we'd monitor the health of our cells. So with vCloud, we have 2 URLs, 2 key URLs that we would use to monitor the status of those cells. And what they would be /cloud/server status or /API/versions. Now a tip we have based on that, and it's something that's not in the documentation currently, is that we'd recommend you to use cloud/server status to monitor your vCloud cells. During a discussion with engineering, it was found that the /API/versions actually puts a higher load on the cells to return a response to that request. Now within what's called the vCloud architecture toolkit, which many of you may be aware of, depending on what area you actually look at, it will tell you a different URL to use, or will give you an example more correctly of what to use. So within the architecture toolkit, if we're looking at the architecting a cloud section, it's going to tell us about API/versions. It does not mention cloud/server status anywhere within that section. And similarly with implementing a cloud, we're seeing /cloud/server status, and again, no mention of /API/versions. So if you've pre-configured to use /API/versions, I'd recommend you to change it. If you're setting it up, then please use cloud/server status. So now that we've talked about the vCloud requirements, let's look at the infrastructure. So again, the product infrastructure, our design here, and how we're going to feed that into our scale later on. So with our infrastructure, it's going to depend on our cluster design. And for example, let's think of our cluster design as small, medium and large clusters. So a small cluster is going to contain small number of hosts per cluster, a large is going to contain a lot, and medium is somewhere in between. Now the figures that we'll see as well in our design, they're going to depend on our underlying products. So the key config maximums, which we discussed earlier. Now we have vSAN as a product in here, so our cluster design will impact the number of clusters we're going to squeeze into our vCenter, and in turn that's going to affect the number of vSAN clusters that we can have. One thing that we need to keep in mind as well is the management overhead of such a cluster design. So will it be easier for us to manage 4 large clusters or 10 small clusters? That is something that we need to keep in mind. So again, just for illustration purposes, let's think of this as a small, medium and large cloud clusters. And again, just for tangibility and to allow the design example to sink in, let's put some figures to those. So we have a small, a medium and a large cloud cluster. Let's put some figures to that. So we'll say a small cloud cluster has 10 hosts, medium has 20 and a large has 30. Now, as we discussed earlier, vSAN has a maximum VMs per host value of 100. So we want to keep below that. So let's say, for example, we have 80 VMs per host. These will give us figures for each of our cluster designs. So a small cloud cluster will allow us to have 800 VMs, medium cloud cluster will have 1600, and a large cluster will have 2400. And what we'll see in the next section is how this is going to feed as we scale out within vCenter and then in cloud. So now that we've talked about all our design elements, let's talk a bit about scaling. So with our scaling, we want to be able to easily add resources. We want to avoid our key config maximums. We want a uniformed approach. So again, this is just going back to our converged versus hyper-converged. So rather than scaling up, we want to scale out. So we don't want to keep adding hosts. What we want is we want to take a design approach and just keep adding that in iterations. And as I've mentioned previously, we want to be able to utilize the environment as much as possible. So let's take an example of a cloud cluster design. So let's take a medium cloud cluster. So as we've seen in the previous section, if we put the values of 20 hosts to it and 80 VMs per host, that's going to give us 1600 VMs per cluster. Now what we're going to do here is we're just going to apply some figures to that, and based on some of the maximums that we have, we're going to see exactly what we can get in as we scale out. So 20 hosts, 80 VMs, 1600 VMs per cluster. Now with our maximum of 10,000 VMs per vCenter, we're just going to divide that by the number of VMs per cluster. And what we'll see is that will give us 6 clusters per vCenter. Now as I touched upon in our last section, the number of clusters that we have within our vCenter is going to define our vSAN clusters. So here, vSAN clusters is going to equal the total number of vCenter clusters that we have. And as you'll see as we go on, all I'm going to do is take some of the values that we already have and take some of the values that we've just calculated, and that's going to be used to get our metrics as we scale out. So we're going to take our 20 hosts that we had and our 6 clusters that we've just defined, and that will give us our total hosts per vCenter. And again, this host's value times the number of VMs per host is going to give us the total VMs per vCenter. And in our example, this is 9600. So as you can see, as we're going along, the figures that we use and the figures that we calculate are all well within our config maximums. So let's take those values and apply them to vCloud. So vCloud has a 30,000 VMs maximum. We're going to divide that by the total number of VMs that we've just seen there. And that's going to give us 3 vCenters per vCloud director. Feeding in this new value into the 120 hosts which we got in our last slide, that's going to give us a total of 360 hosts per VCD. And again, the VMs per host times the number of hosts is going to give us our total VMs per VCD. And this is 28,800, and again, well within our config maximums. So I suppose to take a better look at this, let's compare side by side the config maximums with the values that we have just received. So as we can see there, a lot of the values may be close enough to the maximums, but they're well below it in terms of giving us overhead to expand, but also making sure that we're ideal. So for the sake of fullness, let's include our large and small clusters and see how they would have scaled. And again, we'll just give you a couple of seconds there just to take a look at those figures and see how they sink in. Now what you'll notice is that some of those figures might be the same, but what you'll also see is that even though we're taking 3 different approaches, we're still coming full circle to the same thing. We're trying to utilize the environment as much as possible. And you can see with the medium and large cluster, we have the exact same number of VMs that we're squeezing into vCenter. Now the small might be slightly less than that, but again, we're still utilizing it up to 90%. And what you'll see is the only real difference is the total number of hosts per vCloud, because that'll increase with the total number of clusters that we'll have as well. So a tip that we'll have based on the scaling is that as we're scaling, and again we mentioned scaling out rather than scaling up, so we're not going to be adding new stuff to the cluster, but it may come a time where we actually need to replace what we currently have in the cluster. So if we get a new host or new data stores, we need to add those in as we're scaling. And a recommendation that we'd have here is to decommission in vCloud first. So if we don't decommission in vCloud first, what we're actually doing is we're leaving information in relation to an entity that doesn't exist in vCenter anymore. So vCloud still thinks it exists, vCenter doesn't. And again, this feeds into another issue that we see a lot within GSS. So a frequently encountered issue that we would see, customers may report when they click on the hosts or data stores in a system admin section that they're receiving a blank page. And this is because the hosts or the data stores, again, depending on where they're getting this blank page, something within there has been removed from vCenter without being decommissioned from vCloud first. So as I mentioned, if we decommission it in vCenter, or if we pull it out from vCenter without removing it from vCloud first, we're leaving a reference to an entity. And that reference is actually going to be used in a database view that's being built up to populate this page. So if we're building it based on something that doesn't exist, when it asks vCenter about this entity, vCenter is not going to be able to tell anything. So the view itself can't be built properly, and therefore we can't be seeing any information in the UI. Now, although it is fairly trivial to resolve this, again, this does require a database update, because what we need to do is to remove a value. So my recommendation would be to back up the database and log an SR with tech support. So that brings to a close the presentation, and because we can't do any live questions, here are some of the questions that have been asked when I've delivered this presentation live. So the first question that people tend to ask is, do we need to use vSAN? And I suppose the purpose of this presentation is to use vSAN as an example as we scale out. I'm not here to try to sell vSAN to you in any way. vSAN is part of our storage defined data center, and that's why it's used here. If you do need reasons as to why you would purchase vSAN, then look, we can look to speak to a vSAN expert, or the vSAN sales guy should be able to provide more information on that. Another question that we get kind of quite often is why NSX and not VCNS? Now I've touched upon earlier that NSX is a successor to VCNS, so it has all the features that VCNS has plus more. And just going forward, like, NSX is going to be the future of our software-defined networking. VCNS will more than likely be decommissioned. Again, there's no dates on this that I have in front of me at the moment, but I would expect that VCNS will go away the more customers migrate to NSX. With NSX, there is a feature for layer 2 VPNs via the edge gateways, which is coming in a future release. And with that, you can leverage it to push your VMs or workloads into another cloud, such as vCloud Air. So it's nice to have that kind of feature to be able to extend your layer 2 network. One question that was asked quite a lot would be the compatibility of products. So it's kind of unclear based on our public facing hardware compatibility guide, or product compatibility guide, which of these products works and which work well together. And I suppose my kind of response to that would be that here in GSS we actually have an internal interoperability matrix. So that not only gives us a list of all the products that are compatible, but all the products which are planned to be compatible, and I suppose which ones can really just currently need a rubber stamping. Just because it's not on our public facing compatibility matrix doesn't mean it's not supported and doesn't mean it won't work. It just means that that part of the actual matrix has not been published yet. So if ever in doubt, if you ever have issues about it, then I'd either be referencing the internal interop matrix itself, or if customers have issues, then open a support request with GSS and ask them to reference that interop matrix. Thank you.